All right, so your quiz is on Thursday, and it is on 5.5 and 5.6. So first part of it is adding, subtracting, multiplying, and dividing our functions. So question 1 just asks us to add our two functions together and state the domain. So first thing we have to do, just take our two functions and add them together. So we have 3 x squared plus 1 plus x plus 4. Now we just have to simplify it as much as possible. So I'm going to change it to 3x squared plus x plus 5 because we can combine the 1 and the 4 together. Now I have to state the domain. What's my domain for f of x? This one up here. All real numbers. So there's no square roots, no fractions. Our domain's all real numbers. What about for g of x? All real numbers. Again, no square roots, no fractions. We got all real numbers. So if we combine the two together, what overlaps for our domain of the whole thing? What would our domain of f plus g of x be? All real numbers. So we can't simplify this anymore just because we have an x squared term and an x, so we can't combine those together. So you just want to combine your like terms and leave it as simplified as we can. So this is as simplified as we can go here. I'm going to skip B for now. We'll do that one in a second, but since C involves the adding one, we'll do that next. So all we have to do is plug in -5 into all of our x's here. So we have 3 times -5 squared plus -5 plus 5. So just this -5 is being squared. So what is -5 squared? 25. So we have 25 times 3, and then -5 plus 5. What's 25 times 3? 75. And then -5 plus 5, they cancel each other out, so our answer is just 75. Yep, so this is our f plus g of x. So all we're doing is taking 5 and plugging it into our x's here.
Okay.
Yeah, you plug it in. I mean, you could plug it in before if you wanted to plug it into this and then add it to this one. You'd get the same answer. All right, so let's do B now. So we have f minus g of x. So we take our f of x, which is 3 x squared plus 1 minus our whole g of x, which is x plus 4. So with subtraction, we have to make sure we distribute. We have to distribute that negative sign, that subtraction. So we distribute it to the x and we distribute it to the 4. So this is 3x squared plus 1 minus x minus 4. Combine our like terms. So we have 3x squared minus x. We can combine this 1 minus 4. What's 1 minus 4? -3. So this is our f minus g of x. Now we have to find the domain. So since our domain of f of x was all real numbers and our domain of g of x is all real numbers, what's our domain of f minus g of x? All real numbers. Because it's what overlaps from f of x and g of x. So if we draw a number line, our domain of f of x was all real numbers. Our domain of g of x was all real numbers. So what overlaps is all real numbers. Yeah. So we knew that these were both all real numbers because this is just a quadratic equation. We have that x squared. There's no square roots and there's no fractions, so we have all real numbers. The only time you have to be worried about your domain being something other than all real numbers is if you have square roots or fractions.
Wait, did you have to do the line for that one?
Like this?
Because you already had the square root on it. So didn't we already know that it was all real numbers?
Yeah, I was just giving another example here, so you don't have to do this.
Oh, okay.
All right, next we are going to plug 5 in. Negative 5. So we take negative 5, plug it into our new function here. So we have 3 times negative 5 squared minus negative 5 minus 3. What's negative 5 squared? 25. And what's 25 times 3? 75. What happens to this minus a negative 5? Comes to plus 5. So we have 75 plus 5 minus 3. 77. Any questions from number 1?
On the quiz, will we have that being like one problem?
No.
And then use it?
All right, let's look at number 2. Here we are multiplying and dividing. So let's start with our multiplying. So we just multiply our two functions together. We have 2 times the square root of 3 minus x times 4 times the cubed root of 3 minus x. Can we combine anything together here? The square roots. Yeah, we can combine the square roots. So we can think of this having an exponent. So this would be 3 minus x to the 1/2 power because the square root is the same thing as the 1/2 power. And then this one is 3 minus x to the 1/3 power. Our bases here are the same and we're multiplying. So what do we do to combine these together? What do we do with the exponents? Add them. Since we're multiplying, we combine it to 1 and add our exponents together. So I'm going to do that on the side over here. We have 1/2 plus 1/3. How can we add fractions? Common denominator. So what do we have to multiply to this first fraction here? Got to multiply 3 on the top and on the bottom. And what about on our second fraction? 2. So this becomes 3 over 6 plus 2 over 6. We add our numerators together. So this would be 5 over 6. And then I still just had this 2 times 4, so 2 times 4 would be 8 that I put out front.
Would you have to put it back into the,
You could leave it like this, or you could say 8 times the 6th root of 3 minus x to the 5th power. This would be right, so this is the same thing. Or you could write it as 8 times the 6th root of 3 minus x to the 5th power, like this. I guess here you wouldn't need the parentheses, but these are all the same thing. So these would all be right. So it's just the same way of writing the problem. I like the way that this one looks the best. So I'm going to plug 2 into this one. So again, they're all the same thing, just rewritten a different way. But I just like working with square roots rather than a fraction in my exponent because I would change the index to be out front anyways. So I'm going to plug it into this green one here. So we have 8 times 6, the 6th root of 3 minus 2 to the 5th power. So what do we have to do first to solve? Subtract. What's 3 minus 2? 1. And what's the 6th root of 1? 1. And what's 1 to the 5th power? 1. And what's 8 times 1? 8. So we get 8. Because here when we added, our numerator was 5, so that 5 is our exponent.
So you're basically filling in, like, from the last question what x was?
Yeah, so all I do, I found my problem from the last question, so this was my answer, and I just take the x and plug it into x in there. So I skipped finding the domain, but let's go back to our f and g of x. How would we find the domain for f of x? We have a square root, so we gotta be careful here. How do we find our domain? Awesome. You said what's underneath greater than or equal to 0. Because we can't have negatives under our square root. So we just solve for x now. I'm going to add x to both sides, so I get 3 is greater than or equal to x. So x has to be something smaller than 3, but it could also be equal to 3. So if I had this on a number line, I would have 3 here. 3 is included, so I'd put a closed circle and go this way. It has to be something less than 3. What about for g of x? What's my domain here? If we have an odd index, the cubed root. All real numbers. So this would be all real numbers. Now we only care about what's in common, so that would be from 3 to negative infinity, or negative infinity to 3. Because you always start with the smallest in your domain.
Oh, and this is negative.
Yeah. So whenever you write interval notation, you start with the smallest number. And negative infinity is like the smallest number, so you start with that. So we have f over g of x. So we put our f of x on top. So this was 2 square root 3 minus x over 4 cubed root of 3 minus x. Can we simplify this? Yes? Yes, we can. So just like we did in the last one, I'm going to change the square root to have an exponent of 1/2. So this is 2 times 3 minus x to the 1/2 power over 4 times 3 minus x to the 1/3 power. Now my bases are the same in here, so I can combine them. If I'm dividing, how do I combine the exponents? What should I do? Subtract. So I'm going to have 1/2 minus 1/3. And then I'm just going to divide these two numbers here, that 2 over 4. What does 2 over 4 simplify to? 1/2. So I'm just going to leave that 1/2 out front. And then I combine these to be 3 minus x. And I got to simplify this fraction. So to subtract fractions, what do I need? Common denominator. So I'm going to multiply the top and the bottom by 3 here. What do I have to multiply to the second one? 2. So this becomes 3 over 6 and 2 over 6. What is 3 minus 2? 1. So I get 1 over 6. So to combine the fractions, we need a common denominator. So we have to think, what can we multiply times 2 and 3 to get them to be the same number? So if we had, for example, let's say we had 1/2 minus 1/4. We would have to change our 2 to look like a 4. So what can we multiply to 2 to look like 4?
2.
2. So we multiply the top and the bottom by 2. Because whatever you multiply by the bottom, you have to multiply the top too. Because we're not actually changing the value here. We're just making it look a little bit different. Because 2 over 4 is the same thing that we started with as 1/2. But now that we have common denominators, we can subtract. So this would be 1/4. So you just subtract the numerators together. And the denominator stays the same. All right, now we can check our domain. Our domain's going to be the same as it was when we were multiplying, but the one additional thing we have to check for is we can't have 0 in the denominator. So we're going to set this denominator not equal to 0. And we solve for x. So how would we solve for x here? To check the domain. Because you can't have 0 in the denominator of your fraction.
How do you know you can't have 0?
You can never have 0 in the denominator. So anytime you're dividing, the one additional thing you have to do for dividing is you can't have 0 in the denominator.
But why for this one, why for the top? 2 to the square root of 3 minus 1. And then why can you equal that to 0?
What do you mean?
So you're equaling the bottom here, right?
Yeah.
So why don't you do the top?
Because we only care if 0 is in the denominator, because that would make it undefined. So we can't have 0 in the denominator.
Oh.
We could have 0 in the top. It doesn't matter.
Oh.
The one thing we have to check for is we can't have 0 in the denominator. So solve for x. What should we do first? How do we undo this on the left side? What do we do? Before we do that. Because now we're looking at this whole thing. How do we get rid of that 4? Divide by 4. 0 divided by 4 is still 0. So the cubed root of 3 minus x does not equal 0. How do we get rid of that cubed root? Cube both sides. What's 0 cubed? 0. And now we can add x. So 3 cannot equal x. X cannot be 3. We use the same domain that we had when we were multiplying, so this. However, the one difference is when we have a bracket, that means it's included. So we would put a parenthesis here to show that 3 is not included. So from negative infinity to 3 with the parentheses, because this is not included. All right, last thing we need to do is, yes.
What's the difference between the bracket?
The bracket means that it's included, so we can include 3, but here we said x cannot be 3, so we have to put a parenthesis to show that it's not included. Last thing we have to do is plug in 2. So we're going to use our simplified version here and plug in 2. So we have 1/2 times 3 minus 2 to the 1/6 power. What should we do first to solve this? Subtract. So we have 1/2. What's 3 minus 2? 1. And what's 1 to the 1/6 power? 1. And what's 1 times 1/2? 1/2. All right, so that's it for the first page. Let's go to the second page. Number 3. So another example of dividing. So we take our f of x and put it over g of x. So 2x to the 3/2 power over x to the 1/4. Since our bases are the same, can we combine these? Can we combine the x's?
No,
Why?
because the base is not
X and x aren't the same?
the same. Oh, sorry. Yeah, you can.
Yeah, we can. So we have 2 times x. And then we're dividing, so how do we combine these together? Subtract. So we have 3/2 minus 1/4. What do we have to multiply to 3/2 to get it to have the denominator of 4? 2. So we multiply by 2 and by 2, so this becomes 6 over 4. What's 6 minus 1? 5, so 5 over 4. So we have 2 times x to the 5 over 4 power. Now we have to state our domain. So going back to our f of x and g of x, what is our index for f of x, and can we have negative numbers?
Yeah.
If our index is even, can we have negative numbers? No. So our domain is going to be what?
What was the question?
What can our domain be? But we can't have negatives.
Oh, wait, no, never mind.
Greater than 2?
Okay, so let's change this to look like a square root, since that's what we're used to seeing. So we have 2 times the square root of x cubed. So what's under our square root? Just x. Usually we would say x is greater than or equal to 0. So x can be greater than or equal to 0. So how would we write our domain?
X is greater than or equal to 2.
But we just said x can be greater than or equal to 0.
Oh.
That 2 is not under the square root, so we don't care about it for our domain. We only care about what is under the square root. So it's just x is greater than or equal to 0. So our domain would be from 0 to infinity, because x can be anything greater than 0.
Would you put the bracket?
Yes, because it's included. We can put 0, we can have 0 under our square root.
No, but I mean on the right. Or like the dot on
You don't put a bracket for infinity. It's always a parenthesis for infinity.
it. Oh,
So that's our domain for f of x. Let's find our domain for g of x. Is our index even? Yes, 4 is even. So we can't have negative numbers. So what's our domain for g of x? 0 to infinity. Now the last thing we have to check, since we are dividing, we can't have 0 in the denominator. So we're saying x to the 1/4 cannot be equal to 0. How do we get rid of that 1/4?
By 4.
Not multiply. If 1/4 is our exponent, we raise both sides to the 4th power. So this cancels. So we have x cannot equal, what's 0 to the 4th power? 0. So x cannot be 0. So we said here it was included, but x can't be 0. So we have to use a parentheses because it's not included. So 0 to infinity. Now we need to evaluate when x is equal to 81. So we just take our x, plug it in there. So we have 2 times 81 to the 5/4 power. What is our index here? 4. So we have the 4th root of 81 to the 5th power. What are our factors of 81? 9 and 9. Our factors of 9? 3 and 3. So we circle our groups of 3. So the 4th root of 81 is 3. So we have 2 times 3 to the 5th power. So it's 3 to the 5th power. $243. So 2 times 243. So we get 486. All right, let's look at number 4. So we have to find the inverse of the function. How do we find the inverse? What should we do? So make this y, and then what should we do next? Awesome. We just flipped the x and the y. And then we need to solve for y. So how do we get y all by itself? Subtract the 10. So x minus 10 is equal to negative 1/2 y. How do we get rid of that negative 1/2? So I'm going to multiply everything by negative 2, because that'll get rid of that negative also. So if I multiply the y times negative 2, I have to multiply this times negative 2, and the negative 10 by negative 2. So I'm multiplying everything by negative 2. So x times negative 2 would be negative 2x. Negative 10 times negative 2 would be plus 20. And these cancel. So that's just y. So got to make this the inverse of y is equal to negative 2x plus 20. Now you can write it on the right side, you can write it on the left side, doesn't matter. And remember that negative 1 is just naming the inverse. So you could see it as y to the negative 1 power, or it might say g of x, just calling the inverse g instead of f of x that we started with. So again, just different names of inverses. All right, let's go to B. First thing we have to do is switch the x and y. So x is equal to negative y cubed minus 9. How can we get that y all by itself? Plus 9. So x plus 9 is equal to negative y cubed. What should we do next? Divide everything by a negative to get rid of that negative. So this would be negative x minus 9. And then what can we do next? Cube root. So we take the cubed root to get rid of that cubed. So our inverse, y negative 1, is the cubed root of negative x minus 9. Any questions on this one? All right, C. Change this to be y, flip the x and y. How do we get that y all by itself? Yes. Take the cubed root. So same way we did in the last one to get rid of that cubed, take the cubed root. Yes. So the cubed root of x is equal to y plus 5. What's next? Subtract 5. So the cubed root of x minus 5 is equal to y. Any questions on this one? All right, let's look at D. Change this to y. So we have x is equal to 3 square root y plus 5. How can we get that y all by itself? Subtract 5. So x minus 5 is equal to 3 square root y. What's next? Divide by 3. So x minus 5 over 3 is equal to square root y. How do we get rid of that square root? Square both sides. So this cancels. We get our inverse of y is equal to, you can leave it like this. This would be fine, but again, if this was multiple choice, you would probably see your answer as x minus 5 squared over 9. So just remember that squared applies to the top and the bottom here. So you could see your answer like this too. I wouldn't care if you left it like this here. But again, if it was multiple choice, you would probably see it like this. All right, let's go to the next page. So for these, determining if the functions are inverse functions, I found these examples from the book, but Ms. Fernandez said it's going to take like 20 minutes to solve A and to solve C. So you guys can skip these. You won't have ones that are this hard on the quiz or on the test. So A and C are pretty difficult, so we're going to skip them. But B is definitely doable. So how do we determine if they are functions, if the functions are inverses of each other? What should we do? Awesome. We take the whole g of x and plug it into x in our f of x. So we have negative 2 times negative 1/2 x plus 3 plus 6. And what should we do next? Distribute the negative 2. So what's negative 2 times negative 1/2 x? Just x. And then negative 2 times 3? Negative 6. And then plus 6. These cancel, so then we're just left with x. So are they inverses of each other? Yep. When we just have x as our answer, they are inverses. If we had anything else with that x, they would not be inverses. If it was x plus 1 or negative x, not inverses.